sequences. All right, an arithmetic sequence is found by adding the value to the next one, right? We can add a negative, so that's why we don't say adding and subtracting. Okay. So there we go. Hey, here are some arithmetic sequences. Looks like for the first one, we've been adding 2. Looks like for the second one, we've been adding 20. And for the last one, it looks like we've been adding -5. Those are sequences. So very simple. Hey, we're going to find a common difference. We're going to call that D. That's exactly just what I was telling you right there, right? What is D? The common difference. We don't need it right there. Unless you feel like it. But I'm moving on quickly. Okay. So this is actually important information. I think this is new stuff. So you're going to write a sub 1, that's the first term. A sub 2 is the second. A sub 3, third. So you see the pattern, right? So I have this a sub n. Remember, if you see at the very bottom there, that's just a way for me to name the nth term, right? So if I wanted to know about the 13th term, I would call that term a sub 13. All right, we're going to find a common difference by subtracting a sub 1, a sub 2 minus a sub 1, right? So the term minus the previous term, right? So in other words, D is equal to It is. When I write on that and it comes out fat, when I'm expecting it to be skinny, it's like when you're eating at Bukit Bethel, and they like bring out you order the sundae and they bring it out and you're like, whoa. Like if you order their sundae, it's for like 8. It is literally in a big cup like that. Like literally, like seriously, it's not joking. It's too thick. All right. Yes. Buca de Beppo? Let's find the common difference. What is it? So I use this. Right, so from 1 to 4, I added 3. 3, so D is 3. Hey, what's the common difference here? 6, right? Common difference here. -4. Ooh, how about the common difference here? 2.5. 2.5? Well, let's look at it. I gotta do 3 minus 1/2, right? That's how I would find that. So that's the same thing as this house minus 1/2, which is gonna be 5/2. That's what D is. These will be 3/2, so 6.5. Okay. Ready? Why are you trying to tell me? Okay. Hey, so if we wanted to find the next term in a sequence, we would find the common difference, add the common difference to the last term of the sequence, and continue adding for the specified number of terms. For example, if we're going to try to find the next 3 terms, well, first of all, what is our common difference? 4. So, we just performed rocket surgery. Yeah. It's like brain science, but more complicated. So 17 plus 4 is 21, and then 25. Hey, rocket surgery. Brain science? Well, not really. Call it neuroscience, but okay. Yeah, I really don't care anymore. So, we're just gonna keep recording. It's fun. We're all having fun. Rocket science, surgery for brains. What? Okay. The next 3 terms. Hey. Oh, ready? Oh.
Wait, guys.
Oh, bouncy. We just add D to each successive term. We don't need to get crazy with that. I'm sure that you all can get that really well. You're all very smart. That's all. Okay. Okay. Let's write the first 4 terms of the sequence. A sub 1, that means the first term, right? So that means, hey guys, start at 3. What? I have 4 terms! Yay, it's brilliant, right? Alright, here we go. We'll get to some more complicated stuff too, we just have to work our way up. If we're going to find the first 3 terms, yeah. So let's not worry about that. I think that's okay. This the recursive formula. Hey, not super useful, but something you need to know. You need to know how to write the recursive formula for a sequence. Okay, for an arithmetic sequence and a geometric sequence. So this is actually important. Also, it's very simple. Really, it looks like complicated stuff, but when you fill in this formula, the only thing you're substituting is this and this. You are not changing anything else, okay? Everything else stays the same. You only change, instead of initial, you're going to put a number. Instead of D, you're going to put a number. That's it. Okay? And are we ready? For example, hey, A sub 1 is 1, right? What is D? 6. So then if I wanted to write that recursive formula, it would look like this. A sub 1 equals 1. And like I said, we just leave this stuff all the same, and then we add D. And we have done it. That's it. All you gotta do. It's super basic. Don't try to make it harder because it's not. Ready? No? Okay. This is actually quite important. Explicit formula. This is the thing you'll use the most. Yeah, and what are these lyrics? I know. I'm not good. I learned this in 8th grade. My teacher was bad. Okay. you had a great day. Alright, let's use this thing. Oh, it's right there. Look at that. Okay. Hey, let's do this stuff right here. We'll find a sub 1, find d. We'll plug it in there, and then everything will be awesome. Hey, a sub 1 is 4. What's d? -5. Thank you, Mickey. Oh, no problem. Anytime. What? No? Never make that voice again? Sorry. Okay. What's the final step? Ohana means family. Family means nobody just left behind. All forgotten. That's it, bro. Alright, now that I know, yeah, of course. I did it! I wrote the explicit formula! Hey! Because I've written this explicit formula, I could find any term in the sequence now! If you were to ask me, hey, what is the 36th term in the sequence? All I have to do is plug in 36 for n. Alright. I think that we do this, right? So, yeah. Let's move on. Ready? Hey, this one has already given us an explicit, formula. Interesting. Alright, let's just try to figure out. Well, I don't know why we haven't written it in the way that we have it before, but it's okay. Look, if you need to find the 31st term, all you're going to do is plug 31 in for n, right? So that's going to be 65. So the 31st term is 65. Alright, so whatever you're wanting to find, the nth term, you have the formula. You plug whatever n is, right? So in this case, n is 31, in for n in your formula, okay? Substitution. All you have to do is substitute, okay? You can do it at any time. It's not fun. Okay. You know who's going to No. You don't? Who? Yes. Okay. Hey, okay. Hey, let's do this. Let's find the sequence. What in the world? Ooh, that's my Google's. How did I get caught? How did I paste? I was sending someone a link to my website, okay, and that's what that is. That's the last thing I copied. Why? So hard. Okay. Okay, let's find what a sub 1 is. If we're given all that information, right? So we're saying if I had a sub 13 equals to, so I'm using the formula, right? A sub 1 they said was, we don't know. Ooh, yay. Alright, and then we're going to add that to n. Hey, what is n? If a sub 13, actually I'm gonna go ahead and put an extra step for you guys. Okay. They told me a sub 13 was 16, right? And what is, that means that n is what? 16. No, 13. So this right here, that is n. Okay? That is n. And then we must solve for a sub 1. Super duper special time. 12 times negative 4 is, yeah, and then I need to add 48 to both sides. And that becomes 64 and a sub 1. No, because I added 48 to both sides. Right. Hey, if I needed to find the term number A of the arithmetic sequence, so what are we being told? What are we being asked for? We're asked to solve for n. What if we choose them like this? No? What if that was a thing, though? Maybe you'd have a lot more germs, huh? Okay. So, a sub n, so we're using this formula, right? We're using the formula that says that a sub n is equal to a sub 1 plus n minus 1 times z. What do we know? We know that a sub n is 6. We know that a sub 1 is negative 34. We don't know what n is. We just said that's what we're supposed to solve for. And d is 4. Yeah. I'm going to add 34 to both sides. I'll divide both sides by 4. I could distribute the 4, but that would create more work, wouldn't it? Right? I could save myself some work by seeing that if I divide both sides by 4, I automatically break that out of parentheses. Yeah, bro. I add 1 to both sides. And I get the n of 11 and this is it. Oh. Okay, ready? Oh! Damn! Alright. Geometric series. What's it? Huh? Oh. Wow, that's weird. I wanted to go way ahead. Geometric sequences. Hey, what's the difference? With our arithmetic sequences, we were adding, right? Geometric sequences, we are multiplying. Hey, and in the same way that I said that if we add a negative, that's the same thing as subtraction. So it's actually addition and subtraction. The same thing is true of geometric sequences. Because if you multiply by a fraction, that's the same thing as division, right? If I multiply something by 1/2, that's the same thing as dividing by 2. So we just call it multiplication, but we realize that you could indeed be dividing if you're multiplying by a fraction. And so that's what I just said. Here are some examples. It looks like in number 1, the sequence number 1, we're multiplying by 1/2. Yeah. And in sequence number 2, we were multiplying by 2. And I would have to divide to figure out what in the world is going on. I think I'm multiplying by 3. Yeah. So, okay. You know how we found that common difference for these sequences? We're going to do the same thing, but it's a common ratio. Right? So there is a common factor that is being multiplied, or a constant factor, I should say, that is being multiplied by each term to get the next subsequent term. Yay! We figured it out with our brains. Yay! Rocket surgery! Not brain science. And certainly not rocket surgery. Have you ever done rocket surgery? It's fun. Okay, so.
Mr. Darwin, where do you want me to put these?
Just there. Yay, okay. Hey, let's find the first 4 terms of this. If my first term is 3 and my common ratio is 4, then I just multiply 3 times 4 and I get 12. I multiply 12 times 4 and I get 48. I multiply 48 times 4 and I get... Huh? Whoa. Huh. 160... No? 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 Okay. 160 plus 32. How do you do that so fast? You multiply the tens place and then you add it to your product of the ones place. Oh yeah. Hey, let's find R. How do we find R? We divide. We go. So I'm gonna do this in a mathy way. If we call this one a sub 1, boom, and we call this one a sub 2, right? Then the way that we're gonna figure this out is we're gonna go right. It's a sub n over a sub n minus 1. A sub n here is 2, right? Which means that a sub n minus 1 would be a sub 1, right? And I'm just writing this in a very mathy way, so that's 2 fourths, which is 1/2. I'm sure that you didn't have to do all that. All you had to do was go 2 divided by 4. But all right. Let's find the next 3 terms. What's our common ratio? Well, 6 divided by 3 is 2, right? So then we can find the next terms by multiplying. I don't really see the point in doing that. What's our common ratio here? 3. So we can find the next terms by multiplying, right? Yeah? We don't need to get crazy on that. How about this one? It's possible for R to be negative, right? 16 divided by 32 is negative 16, right? So R is going to be equal to negative 1/2. And you could have a negative value for R, right? If you have a negative value for R, you're going to see that it's going to flip-flop, right? It's going to go negative, positive, negative, positive, negative, positive, negative, positive, right? Just because you're adding a negative by a negative, and a positive by a negative, and so on.
Who wouldn't want to be moving? And then he cut himself open and like.
Right. Is this one geometric? Let's see. R for this one. 6 divided by 3 is 2. 2. What's 18 divided by 12? Not 2. So the answer is no. Your parents' favorite word. Yeah. Okay. Ready? Ready? Not ready. Okay. Hey, the first 5 terms! Yay! Ooh, it says click on it too. Hey! Hey! It makes sense, right? I mean, seriously, I don't want to spend much time on that at all. It's so easy. All you gotta do is start with the first one, multiply, 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 multiply. Yeah? Okay. I can tell by these. Hey, this is important. The recursive formula, again, not very useful, but you need to know how to do it. So you do need this formula. This formula is important. Okay, here we go. Let's find the recursive formula. A sub 1 is 0.5 or 1/2. What is R? R is negative 2 divided by 0.5. I had to convert that to a fraction to do in my head. Because negative 2 divided by 1/2 is much easier to do. Click and multiply, and you get negative 4. So what's our recursive formula? A sub 1 is equal to 0.5 and A sub n equals, sorry, I forgot what the formula was. Times A sub n minus 1 times, we're going to use a dot, not an x. Please don't use an x. I hate that. It really drives me quite nuts. You're not going to use a lot of gas on that drive, but it still drives me nuts. It's going to be a short trip. Yeah, that's always a fun thing to say when someone's like, "You're driving me crazy." You tell them, "At least we'll get there fast." All right. Okay. Okay, Beverly Hills. Ready? Here's our explicit formula. You also need this a lot. It's important. There's our formula. So it's r to the n minus 1. That is an exponential equation, isn't it? R to the n minus 1. Means we're going to have to do some logarithmic work at some point in time, huh? All right. Hey, let's write the explicit formula for this one. So, a sub 1 is 2. R is equal to negative 1/2, right? So then a sub n, we'll plug that in there. A sub n is equal to 2 times negative 1/2 to the n minus 1 power. Done. We did it.
We did it. Oh, wait.
Ready?
Oh, you little smart man in a wheelchair.
Yeah. Okay. Hey, let's find a specified term. Let's find the 10th term of this sequence, right? So, how do we denote the 10th term? A sub 10 is equal to 3 times negative 5 to the 10 minus 1 power. So, a sub 10 is equal to 3 times negative 5 to the 9th power. We're going to have to put that in a calculator, aren't we? Hey, don't you dare multiply 3 times negative 5 first. Don't you do it. Don't you do it. What's negative 5 to the 9th power? Dang it. That's 3 times negative this number. Alright, so we're going to find R. So there's our formula. We're given that a sub 6 is 0.02. So that means that, not 0.02, but 0.2. I can plug a sub 6 in for a sub n. A sub 1 is 625. We don't know what R is, but we know that n equals 6. So we have 6 minus 1. We're going to have to solve this for R. So that's R to the 5th power. I will divide both sides by 625. Okay. So I get so then I raise everything to the. Sorry, I need to take the 5th root of both sides. So I'm going to go R is 20. All right, moving along. Okay, so let's use our recursive formula, or not a recursive formula, but our explicit formula, in order to calculate this. So, a sub n, yes,
What are you going to do last grade in Jacob?
Friday, the test use. Alright, so a sub n is 98,304. A sub 1 is 6. R is 4. To the n minus 1, we have to solve this thing for n. So first thing I'm going to do is divide both sides by 6. It's 163.9 equals 4 to the n minus 1. How do I get that n minus 1 out of that? Out of there, I'm going to take the log of both sides. Let's go log base 4, because it'll save me some time and energy and effort. Alright, so that's going to be log base 4 of 163.9 equals n minus 1. And the log base 4 of 4 is going to go away. So I get log base 4 of 163.9 plus 1 equals n. I'm going to go ahead and calculate that. I get something wrong on my calculator. Oops. 98,304 divided by 6. Oops, I accidentally hit the decimal button. And it turns out that actually 4 to the 7th power is 16,384. So n is 8.